Tamam. Adaptöründe bir numara vardı. Bu benim kartım. Bunu kaybetmeyeceğim. Adaptöründe bir numara var. Bilmiyorum ne olduğunu. Senin micro kartını biz kullanıyoruz şimdi. Şimdi ben nasıl karıştırmadan? Tabii elinde 2 tane micro kart var, içinde şeyler çekiyor şu an değil mi?
Çekiyor hocam.
So this is what happens. Interrupt process involves taking the interrupt. Okay. When the interrupt comes, my process starts and the current instruction. I go to this is the kernel. Okay. When the interrupt comes, I come to the kernel. Okay. There is a dispatch handler. That means that okay, there are many types of interrupts. Some of them are IO interrupts, some of them are different types of interrupts. I need to know what kind of interrupt it is from this line, number 3. Once I know that what kind of interrupt, I can choose what type of interrupt handler I'm going to use to handle that interrupt, okay? I choose that interrupt handler and I run it. After I run that interrupt handler, I'll transfer all that data, then I go back to my next instruction, okay? So this is what is happening with the interrupt. It's a complicated set of processes, complicated set of procedures to handle I/O in an efficient way. Efficient in terms of CPU time. The interrupt controller might be another computer, like it might be another CPU, or the DMA chip. It might be another CPU. The thing is that we are trying to use the main CPU. The thing is that we are trying to make the efficiency of the main CPU high. See, this USB controller might be a computer. This one especially, the hard disk controller is a computer actually. It has its own CPU, but it is less expensive than this CPU, much cheaper. Okay, and I can waste the time of this hard disk controller CPU. I prefer wasting. If I want to waste time, I prefer wasting time of this hard disk controller, not the main CPU. Okay. Again, it is almost the same as saying this. Okay. Remember this picture? This one. This is a very expensive computer, $1 million. It's not that expensive. This is $100,000. Okay. I can use this computer and this computer for doing I/O stuff. But previously in the 1940s and 50s, people used to bring the data in and out. Nowadays I am using those system buses. So idea is kind of the same. I can waste the time. I can waste times of these two cheap computers, but I want to make this as much efficient as possible. Okay. So we will talk about, again, as I said, we will go back to the history and we will talk about more. We will talk more about the similarities to the histories. Okay. Ya bu ders benim kafamı bozuk duruyor ders saati. Herkes çakışıyor. Aranızda anlaşın, bana şu saat olsun diye ona göre bir şey yapayım ben. Aranızda anlaşamıyorsunuz yani. Böyle bir şey yaptığınız zaman herkes birbirinin arkasında.
3. sınıfın diğer dersleriyle çakıştırmaya çalıştıkları için anlaşamıyoruz hocam.
Yine bu ders 3. sınıf dersi.
Tamam, öyle işte.
3. sınıfın diğer dersleri nasıl çakıştırıyoruz?
Pazartesine koymayı istiyorlar veya salıya. Başka 3. sınıfın dersi olduğu zaman.
Sen nesin peki? Sen 4 müsün?
Ben 3. Ben çünkü 3.
Sen
sınıfın dersleri... Evet.
Öbürleri de 4. sınıfın derslerinin olmadığı zaman koymaya çalışıyor.
Evet.
Oluyor. 2'lerde, 2 yok değil mi burada? 2'den ders alanlarda
Sistem alanlar falan burada.
çözümü yok değil mi bunun? Akşama koysak
Hocam ben baktım bayağı
5'te yapar mısınız? Belki olur diye. Ha?
Ben inceledim de yani.
Gerçi söylemeniz lazım. Çünkü yasak bir dersler.
Ne var? Sistem mi var? 4'ten işini
Ya bana zaman bulun değil, şu saat olsun falan diye oraya koyalım ama yok bulamıyorsunuz. Ondan sonra dersin sözü bir şey çıkıyor.
Hocam 4'ler bu dersin...
Saat söyle. Saat söyle. Ya ben bana
Yani
problemi çözemiyorum.
9'da 12 arası dersleri var. 4'lerin o dersleri almak istiyorlar.
Bugün.
Yani, evet, bu saatte dersleri var. Bu dersi kaydırmak istiyorlar. Onun için.
Onu
Yani,
anlıyorum. Bana saat söyle, şu saat olsun.
Pazartesi 1-3-5. Hocam pazartesi 3-5.
Pazartesi 3-5.
sizin dersiniz yok mu hocam? Doğal dil işleme yok mu?
Pazartesi sabah dersi ben PS için diyorum.
PS her zaman ders olmayacak ya.
Ben diğer dersimi kaydetmeyeceğim zaten. Diğer dersimi koyduk oraya. Problem PS değil mi problem?
Evet, PS.
Pazartesi sabah problem var mı pazartesi sabah? Yok değil mi?
Normal dersimiz var.
Pazartesi 11'de ne var peki?
İş hukuku.
Girmiyorsunuz ki ona.
İş hukukundan sonra dersiniz var mı?
Eğer aranızda anlaşırsanız tamam mı? Yani
Hocam,
birkaç
pazartesi
kişinin
3-5
belki
bence
olabilir birkaç kişi tamam ben sizi görmüyorum falan derim.
Hocam pazartesi 3-5 herkes
Yarın da
söylüyor.
ifade ediyorsunuz. Tamam tekrar dönmeyeyim ben ya. Bana zaman söyleyin. Uyuyor değil. Hayır itiraz ediyorlar. Ben gelmek istemiyorum pazartesi gibi.
Hocam bizim doğal dersimiz var zaten.
Hayır, PS.
PS için diyor.
Necmettin hocam.
Hocam pazartesi normal dersimiz var. Gelecek zaten. Gelecek o gün. Pazartesi gelecek dersinden sonra
Söyledi ya şey vardı, bir hukuku vardı. Bir aranızda anlaşın. Ben onu göreceğim her çok az itiraz gelirse bir iki kişi. Biraz da şey yapmaya çalışın arkadaşlar yani ben o günün boş ya gelmeyeceğim ya falan yapmayın. Tamam mı? Gelin onun için yani birilerinin problemi var halletmeye çalışın. Ben akşam saat 5'de ders yapmaya razıyım tamam mı? Varsa eğer yapalım diyorsanız tamam. Yakanlığı falan da halletmem lazım. Akşam çünkü ders yapmak yasak. Ona bile razıyım. Sabah erken gelmeyin. 8'de başlayabiliriz. Var mı? Olur mu? Ben o kadar fedakarlığı yapacağım. Siz de aranızda bir şeyler yapın artık. Razı olun bir şeylere. O gün benim boşluğum düştü, şunu yapacaktım falan ben ne bileyim. Okay. Go back to the operating system concept. Let's talk more about I/O devices. As I said, we can use computers to help this computer. We can use a CPU to help this CPU. For some of the controllers, these controllers, they have their own CPUs and they have their own computer. That means that you are running another operating system here. Okay? You can run an operating system because this might be a full computer. Okay? Because it has a very complicated task. The task is to interface this drive with the CPU. It might be very, very complicated because this drive has a very complicated mechanical mechanisms and there are other electronic stuff. It has to do many things at the same time. It has to optimize many things. So this controller might be a computer itself with a complete operating system. Okay, but its task is to make the life of the CPU, the operating system, easier. Otherwise, I cannot control this drive by myself. So what I am saying is that with these procedures, even though they are complicated, what I am trying to do is to abstract the underlying hardware for the upper level operating system or the user. Okay, let's talk a little bit about buses. In this, remember that simple picture 27. We say that there is a single bus, like that, and everybody is connected to this bus. It used to be like that in 1985. 1985, you had just a single bus on a PC, personal computer of course. You had a single bus. On that single bus, everybody sits on the same bus, and everybody communicates on that bus. That's why that bus is slow. That bus has to be very wide, and physically it is very, very long. Nowadays, we don't use that kind of buses because we need some of those devices. We need some of those devices running very, very fast. We have different type of buses. We have this DMI bus, we have this PCIe bus, and we have the PCI buses, okay? So if this is my CPU, 2 cores, okay? And there is a very fast bus inside this CPU itself, and there are other buses, dedicated buses. For example, for this graphics unit, graphic unit has to communicate with the computer, with the CPU, very, very efficiently, because you are showing 100 frames per second on 2 or 3 displays, okay? And when you are doing this, you should not spend much time transferring the data back and forth. And nowadays, as I said before, we have these GPUs, okay, graphics processing units, and people have been using those GPUs doing some scientific work, scientific computation instead of doing the graphics. And you need to transfer lots of data to the GPU back and forth. So this bus has to be very, very fast. Okay, so memory, you need to access the memory in a very efficient way because we need data, even though they are slower than the caches and inside the core registers, still we need to access them very, very fast. That's why their buses are different. And then there is the platform controller hub. There are many buses, okay, there are many slots connected to this device, and we have this bus. So what I'm saying is that with the buses, there is no single bus anymore. There are many different buses with different capabilities and with different speeds, okay, with different speeds. Otherwise, I cannot hold all the devices at the same time. So we are not using a single bus anymore for faster I/O devices and CPU to memory traffic. The main bus is PCIe, Peripheral Component Interconnect Express Bus. There used to be a PCI buses. Before that, there are many, many different types of buses. And we have these direct media interface, DMI buses, and the DDR buses like this one. Okay, those are the memory buses so that we can access the memory in a very efficient way. Okay, what else? There is this USB bus, universal serial bus. This USB was designed to make the life of accessing the serial devices in an efficient way. It used to be slow, like this slow. Nowadays, I cannot call this slow anymore. Okay, it is 6 gigabits per second, which is how many times? 6,000 times? No, 3,000 times, right? 3,000 times faster than the original USB. It used to be this one, the SCSI buses. It used to be the fastest bus available then, but USB 3.0s are now much faster than those types of buses. This is a very old standard from 1980s. They made it better and better. They say, as I said, it is old and it is very fast, but USB 3.0 is now faster than many versions of this SCSI bus. Okay, so we have no shortage of buses, different types of buses, different capabilities, and they keep adding new ones. Okay, one nice thing about this USB bus is that it is hot pluggable. What do I mean by hot pluggable? I don't need to reboot my computer after I plug in my USB device. I don't need to reboot my computer. The rest of them, when you connect a SCSI device to your computer, you need to reboot your computer. You cannot electronically. It is not possible. You might hurt your device. So one advantage of USB is we are taking it as granted to connect your USB device when the computer runs, but it is something complicated, both electronically and the system-wise. Okay, let's talk a little bit about booting the computer. When the computer is booted, when you turn it on, when you turn your computer on, it has to run some kind of a software, an initialization software. And it is not the operating system, because the operating system is a program and it has to be loaded to the computer first, right? So who does this? It is done by this unique software called BIOS, Basic Input Output System, okay? When the computer is booted, there is a special read-only memory on the computer parent board or motherboard, read-only memory, which contains this software. basic input-output system. It's a kind of an operating system, but very, very primitive operating system, okay? This BIOS system, it starts running immediately. It's an operating system. It starts running immediately. It first checks how much RAM is available, what type of RAM I have, and it checks the I/O devices too. Do I have any disk drive? Do I have any flash drive, etc. Then after it checks everything, all the RAM and the CPU capabilities and everything, and it decides which device, which I/O device should I load my operating system. Okay, the operating system has to be loaded to the CPU, to the memory. So it makes that decision. It could be either the USB device, USB flash drive, or the hard disk drive, or sometimes from the network. You might load your operating system from the network. So once that decision is made, then your operating system is loaded, and your operating system takes over the control of the CPU. So when the operating system, when the computer first starts, with this slide I am saying that it's called booting. I am saying that the operating system has to be loaded first because it's a program. Once it is loaded, then it will take over the computer, and it will manage the computer until the computer is shut down. Okay. So the task of the BIOS is to see what kind of devices I have, okay, and where to boot my computer, where to load my operating system. Any questions on BIOS? They keep changing these names. Nowadays they are not using BIOS, I guess, but it has to be done. You don't have the operating system with the computer all the time. It has to be loaded. Okay, let's go back and try to remember what we were doing. We first, at the beginning of the chapter, no, I don't have the overview here. At the beginning of the chapter, I talked about the definition of the operating system. Then we talked about the history of the operating system. Then we talked a little bit about the hardware review. That's what I have been doing now. Now we are going to talk about different types of operating systems. Okay, there are many different types of operating. After this, we will talk about some concepts about some common concept of operating systems, and we will end the chapter that way. Then, as I said, this is a kind of a summary of the whole course, the whole semester course. We will go back and start from the first concept, which is the process concept. Okay, so let's look at the types of the operating systems. These are the main types: mainframes, servers, multiprocessor operating systems, personals, handhelds, embedded, sensor node, real-time, smart card operating. These are the different types of operating systems. Don't take these as different. I mean, server operating systems and multiprocessor operating systems, they intersect. Sometimes they are the same, okay? The same operating system could behave as a personal computer operating system, multiprocessor operating system, and a server operating system. So don't think these operating systems as exclusive operating system, okay? Some of them are really, I mean, if an operating system is a smart card operating system, it's a smart card operating system. You cannot use it as a personal computer operating system, but some of them can be used as both personal computer operating system and the multiprocessor operating. For example, the operating system on this computer, it is both personal and the multiprocessor, and it can behave as a server too. And since I can carry it, it's a handheld operating system too, because I can carry it, right? Handheld means that I can hold it in my hand, and without connecting to the power outlet, I can use it. So when I talk about the types of the operating system, always keep this in your mind. Mainframe operating system. So these are the first types of operating systems. in 1950s, 60s, we used to have, I mean, dominantly we had mainframes, other than the mini computers. We had the mainframes, and the mainframes are very large computers. These are room-sized computers. You need to cool them down. They are air conditioned. There are many operators that run these types of computers. With the mainframe, everything has to be big. You have thousands of disks. I mean, this is not exaggeration. Thousands of disks and millions of gigabytes of data. Millions of gigabytes is like hundreds of terabytes of data, maybe thousands of terabytes of data. Okay, available for this mainframes. What they do is they do batch processing. What is a batch processing? It does one job. After the job is over, it does another job. Okay, there could be very big jobs. For example, one of the uses for the mainframe operating system is the CPU service. It does some weather forecasting, right? You load all of your data and you try to estimate how the weather is going to be next day. Okay, so you have all of your data. You need to run some kind of an algorithm for a single day with your 2,000 processors and 2,000 disks. So there is no I/O process involved. There is no user interaction involved. You need to run this process for the next day so that you can get the results. After it is done, you start doing the next day's forecast, or you can start doing the forecast for some other country, some other city. So it is batch processing. In the transaction processing, you have I talked about this before. At the end of the month, you need to calculate how much money you are going to pay to your employees. If you have 100,000 employees, that's a problem. So it has to be done by the transaction process. It is doing the same thing over and over again with 4 different persons. Okay, or the transaction processing for the customers. Okay, your customers are bank customers. They are withdrawing money or depositing money, and you need to calculate how much money is available in their accounts. It has to be calculated. So this is transaction processing. Small tasks, but you need to do them by the millions. Okay, so it's a transaction processing, and sometimes mainframes can be used with the time sharing, which is with the users. But these two are the main things for the mainframes. They always say that mainframes are going to die. They always say that mainframes are going to die, but they never die. They always come back because there is always this bad jobs and transaction jobs. Okay, and for these you need lots of CPUs, you need lots of disks, you need lots of I/O capabilities. Okay, this IBM system OS 390. I think it is descendant of one of the mainframes from the 1960s. I think it used to be OS 360. I think it was like that in the 1960s. So it is still being used, and it has its own operating system. But nowadays, people are running Linux and Unix on some of the mainframes. They are still very expensive. They are very expensive to buy. They are very expensive to maintain because you need special rooms. You need many people to run the mainframes, but we need them. If we didn't have these mainframes, then I had to do the same thing with the smaller computers, which is not that efficient. Okay, so these are the mainframes. Related to mainframes, we have server operating systems. By server, we mean that we serve multiple processes, we serve multiple users over the network. Serve multiple users at once over the network, allow the users to share hardware and software resources. For example, the CPU servers. Okay, if you have a good enough machine that can do some computation very fast, and make it a server so that 50 people can use it at the same time. They can take turns, or they can use it at the same time. Or the web servers. You have a web server, okay, 1,000 people can log on it and get your data from the web. Okay, these are all good server systems. Mainframes could be servers too, right? Mainframes could be used as servers with this example, with the time sharing example, right? Servers can provide print service. Okay, if you have for most of the large universities, there are print services, okay? They have 50 printers connected to a print server. Everybody sends their job to the print service, print service, and the prints are printed using one of those 50 printers, and you get your printout from the computer center. So you need a server for that, okay? Sometimes, for example, Dropbox is my file server. I use it as a file server, some web services. Nowadays, Unix variants, like the Linux or the FreeBSD, or these are all Unix variants. So that is, this used to be from some microsystems. Again, a Unix variant, and this is a Unix variant too. So these are all based, most of them based on the Unix system, server operating systems. Multiprocessor operating systems, you have many. Again, this is related to servers and the mainframes. If you have more than one processor, and that means that you can more efficiently run more than one process at the same time. You don't need to do the time sharing. If you have 4 processors, you can run 4 processes at the same time, which makes it very efficient, but it makes the task of the operating system more complicated. So to handle more than one processor, you need a multiprocessor operating system. Okay? These used to be very special operating systems, maybe 20 years ago, but not anymore. Why? Because even the cheapest CPU nowadays has more than one core, right? So you can run more than one program at the same time. Even the handheld computers like these, they have more than one core. So everything is becoming all the operating systems are becoming multiprocessor operating systems. Conventional desktops and notebook operating systems are starting to deal with the multiprocessor. Okay. The hard part is operating system has to be complicated, but the hard part will be the applications. If my application can use more than one processor at the same time, it's good for me, but writing those applications is not that easy. Even if you don't have those kind of applications, my operating system can run more than one process at the same time, which makes my computer faster, overall faster. Okay, these are the multiprocessor operating systems. What else? We have personal computer operating systems. Not much to say about it. We know about Linux and the Windows and the Apple's operating system. They have long histories, starting from the 1960s and 1970s. They used to be very, very weak, not that sophisticated operating system, but nowadays, this one, they are all complicated. They are very robust operating systems. But as we talked about the handheld computers, and these are the operating systems for the handheld devices. We know a few of them, like this most famous ones, the Android operating system and the iOS operating system. BlackBerry has one, and the Symbian has another one. But these two are dominating the market today. They have different issues, like they are not much that different from the personal computer operating system, but the interface has to be simple to use. You don't do much complicated stuff, and battery management is something that you need to deal with the handheld computer operating systems. Other than that, handheld operating systems, we have embedded operating systems. Embedded system means that embedded system is a computer. It has its own operating system on it, but it's a special computer because on an embedded computer or an embedded system, you don't run your own software, right? What are the examples of embedded systems? TVs, okay, microwaves, microwave ovens, okay, or your washing machines, or your dryers, whatever you can name it, okay. Each one has an operating system on it, but you don't run your own software. It comes with its own software. It has hardware on it. Hardware is the embedded system. This is hardware. This is the operating system, and this is the application software on it. This application software is written by the producer of the hardware. When you produce hardware and the operating system and the application software, that means that you know from the beginning that you're going to run this software on this hardware. So you can be very careful about your application. The problem with the personal computer operating system is that the designer of the operating system doesn't know what kind of application is going to run on it, right? That's why it has to be prepared for all kinds of situations. For this one, you don't have to be that careful because you are writing your application yourself. That's why embedded operating systems, they don't have to pay much attention to protection, because since the software is their own software, in terms of protection, they don't have to be very careful, because if the application is making an error, it's your application, then fix your application, okay? So there are some advantages. What is the disadvantage for this kind of operating system? Usually this hardware is very, very small, not much memory, okay? Not much CPU power, and you have to run your application and the operating system at the same time on this hardware. So you need to write very efficient code. How do you write efficient code? You use either assembly language, or machine language, or C programming language, right? So it is difficult to program. They are difficult to program and maintain, but as I said, you don't have to be very careful about the fairness. A very, very important problem for operating systems. Or you don't have to be very careful about the protection. If I run two applications on this machine, application 1 and application 2, I don't have to worry about application 1 messing up application 2's memory space, because both of them are mine. If I am careful, then I can manage it myself. I don't have to rely on the operating system. Okay? No need for protection. Linux has an embedded version. QNX and VxWorks are some popular embedded operating systems. They used to be very, very weak. The hardware, CPUs, very, very weak, not that strong, not that capable. But nowadays they are becoming more and more powerful. So their operating systems are becoming more and more powerful too. Some people are doing Java programming in embedded systems. So Java and embedded systems like 10 years ago was unheard of. It was funny. Nowadays it's not funny. They are doing some embedded system programming using the Java language. Okay, let's take 10 minutes of break. After the break, we are okay.